Hello everybody, here is the problem that you thought about today. We've got this piecewise defined function. I've fixed the domains so that they don't have a problem anymore. I want to know, what is this function when composed with itself? In other words, what is g of x? So this is an example of an extending your thinking question where you already know all the math you need in order to answer it, but it's not obvious how to apply the math that you already know. So you need problem-solving techniques, not more math facts. So here are two problem-solving techniques that we talked about in class very briefly. One idea is, instead of trying to find the entire solution all at once, you should try and focus in on just one piece of the solution, just one aspect of the solution, just one part of the solution. And another idea is systematically test small cases or small examples and look for a pattern that will help you try and answer the large question. So I want to illustrate kind of what it might look like to try and use these two approaches. Something that somebody had suggested was you could try to just compose the different function rules just with each other. So in other words, let's guess that g of x is really like x squared plus 1 composed with itself. So x squared plus 1 squared plus 1, and then 1 over x minus 1 composed with itself, like this. So that's a good guess, but it's just that, it's a guess. Like, how do I know that this part needs to get composed with itself and this part needs to get composed with itself? You could test this guess to see if it makes sense. One thing you could do would be plug in different values for x, figure out what is g of -4, or what is g of 0, and then see if you get the same thing for this function. So you could test it, but really this was just a guess. And sometimes you get lucky with your guesses and sometimes you don't. But I want to try and focus more on what could we do to make ourselves more confident that this guess either makes sense or doesn't make sense. So let's start by systematically testing small cases. Let's let's just choose a number. Let's say g of -3. What's that? All right, so g of -3 looks like it's 9 plus 1 is 10. So that's going to give us g of 10. So now, because 10 is larger than 0, it goes through this piece. So g of -3 ends up being 1/10 minus 1. Or in other words, so this would be like 10 over 10. So this would be like -9/10. Okay, so we've got a number. A couple of things that you could do. One thing you could do would be to start making a graph to think about like what does the graph look like. What I want to focus on is this process that we just went through. First, -3 went through this piece of the function, then it went through that piece. So why is it that it went through this piece and then that piece? That's kind of what I want to zero in on. And in particular, I want to notice that we have started getting information about the final answer. I know that there is some piece of this function, and I don't know what the domain is, but I know that x equals -3 is part of it. So whatever is happening here, it includes x equals -3. And what I did was I composed that piece with that piece. So I did this one first and this one second. So if I was going to write that as a function rule in general, it would be, what, this one first, that one second. So it would be 1 over x squared plus 1 minus 1. So let's just double check that that makes sense. I know that when x is -3, I'm going to use this part of the rule. So that gives me, let's see, 10 and then 1 over 10 minus 1. Yeah, that worked. So what I did was I took the specific path that I took for a particular input number, and I thought, what does this tell me in general? So would the same thing happen for other inputs? What about x equals -5? Let's think about it. So if x equals -5, this number is going to turn out to be like 26, and so then I'd take the 26 and I'd plug it in here. So that makes sense. I'd still do this followed by that. So the same composition rule works. So now we've started finding part of the solution. We know that that is the right rule for some domain of the function. And you can start thinking about the next part of the solution. Like, what x values can you plug in where first you evaluate this function and then you evaluate that function. Let's do another one. Let's say we find g of, scratch that out. Let's do g of 10 and see what we get. Okay, so g of 10, we'd plug in here. So that's 1/10 minus 1 is negative 9/10. So then we'll find g of negative 9/10. Oh, and it looks like now we're using this rule because our input was negative. So let's see, negative 9/10 squared is 81/100 plus 1. So that would be like 181/100. So now we found another piece of our function. We first evaluated this piece, and then we composed it with that piece. So we had 1 over x minus 1, quantity squared plus 1. And again, we don't know what the domain was, but we know that x equals 10 is part of whatever domain involves composing in that order. So you can now start to ask yourself what inputs end up getting composed in that order. And then we've got another question. Is there another piece, or is it just 2 pieces? Maybe there's 4 pieces. I don't know. But I hope to show that this is kind of illustrating how you might use logic with the math facts that you know in order to start piecing your way through this problem. Like I didn't do any magic here. All I really did was I just started plugging in numbers, and then I started asking myself, what is really happening when I'm plugging in the numbers? And what does that tell me about parts of my final solution? So I'm not asking myself, like, what's the next step to get the answer? Because the whole point is I don't know the next step to get the answer. What I'm trying to do is I'm trying to make sense of the situation and fill in little pieces of information wherever I can, like putting together pieces of a puzzle. And then eventually you get the answer. So I hope that this was helpful. Good luck.